4.3, naming and writing ionic formulas. When we're doing this naming, we first got to identify if it's an ionic compound so we know which set of rules. And we do that because the first one's a metal. So you'll notice the guide to naming ionic compounds with metals that form the single ion. So we're first going to identify the cation and the anion. We're going to then, step 2, have the cation be given by its elemental name. Number 3, we're going to change the name of the anion by dropping the end of it and adding "-ide." Number 4, we're going to put it all together, making sure that the cation is first and the anion is second. So as we look at this table, here are some examples. Our metal is first, KMgAl. Notice the anion is second, and we change the ending to "-ide." Name the ionic compound K2O. We first identify the cation and the anion. Our K is first, that is our positive one. That's going to be the metal. Our O is the anion, the negative one, so that is going to have its name changed to IDE. So then when we put it all together, we have potassium oxide. Press pause and see if you can write the names of the following compounds. We're going to identify the cation and anion first. Our calcium, our Ca, is the metal. Our O, we know by now, is our oxygen that we change the ending to IDE. And our Al and our Mg, our O and the Cl. So our calcium, our aluminum, our magnesium. Notice we didn't change the name at all. However, with the anion, we change the name and put an IDE. So oxide, oxide, chloride. When we put it all together, we have calcium oxide, aluminum oxide, and magnesium chloride. Press pause and name these following ionic compounds. Magnesium bromide, aluminum selenide, potassium sulfite. Notice how these ends have changed to IDE. Silver oxide, scandium nitride. Notice how nitrogen is changed to IDE. Zinc oxide. Well, some metals can be more than one charge, and quite often that happens in the transition metals. So here's the ones that most commonly can be more than one charge. So I'd like you to remember copper, iron, our lead, and our tin are going to be more than one charge. If metals are more than one charge, we must identify that with a Roman numeral when we're naming them and writing out the name. Now, I do want to point out, as we're looking at our periodic table here, remember how we really didn't talk too much about the transitionals when I was asking you to predict what charge that they would have. Well, as a whole, now we'll talk about this, as a whole, one of the charges that they have quite often is a +2 charge. There are exceptions. First of all, silver is always a +1 charge. Need to remember that. Put that down and star it. Now then, over here in the group 4A, which are not transitionals, yes, they are a +4 as predicted, but sometimes they can be a +2. So, let's go ahead and remember that we are going to use a Roman numeral when we're writing it out if it's going to be a metal that can be more than one charge. And here's the examples, and hopefully you remember your Roman numerals. Here are some other examples. Just look at your periodic table that the sapling gives you for the more than one charge. All right, the guide to naming the ionic compounds when you have the metals that can be more than one charge. You have to determine the charge of the cation from the anion. You name the cation by its elemental name and use a Roman numeral in parentheses for the charge. Step 3 and 4 is the same as before. Here's an example. The CuCl2. Because copper is one of those that can be more than one charge, if I say name this compound, then you got to figure out what charge it is. Well, we look at its partner, its anion. The chlorine's a halogen, it's a -1 charge, but I got 2 of them. So 2 times -1 is an overall 2 charge. That means our copper must be a +2 charge. There's only one copper atom, so it is copper 2. So we would name that as copper, Roman numeral 2, in parentheses, chloride. Name the ionic compound FeCl2. First of all, determine the charge of the cation by looking at the partner, the anion. Well, our chlorine, when it becomes a chloride, becomes a -1 charge. Why? Because all halogens do. I have 2 of them, so that means it's an overall -2 charge, which means that our iron, total charge must be a +2 to balance out the -2. I only have one atom to spread that charge over, and so we're going to have iron be a +2 charge. And so when we're writing it out, we're going to say iron 2. We're going to put the ending chloride on, iron 2 chloride. Press pause and name these ionic compounds. Step 1, our iron needs to, because it can be more than one charge, we've got to figure out what charge it is. We have to look at our oxygen. We know that the oxide ions are always a -2, so 3 times -2 is an overall -6 charge. So that means our iron must be an overall 6 charge. But we look to see how many atoms we have to spread that 6 charge over. Oh, we have 2. So 2 times what number is 6? It's 3. Or, if you want to take the non-thinking way, that I have given you the permission anytime you see a 2 and a 3, we're just going to cross them and put them in the other position. So in that case, it would be a +3 charge here and an O with a -2. B, we do not do that cross with anything other than 2 and 3 because sometimes it'll mess you up. And I don't want you to miss like 50% of the time. So we're going to think this one out. Chlorine's a -1. 4 times -1 means an overall +4 charge over here. I only have one atom to spread this +4 out, so that means our tin atom must be a 4+. So when we put it all together, we're going to be using iron with the Roman numeral 3 and tin with the Roman numeral 4. Oxide and chloride, when we put it together, we have iron 3 oxide and tin 4 chloride. Press pause and name the following compounds. All right, first one, lead 2 oxide. Why? Because it's a 1-to-1 ratio. The oxide ion is always a -2, so that means we must have a +2. So we're going to have lead 2 oxide. Now then, on our O2 here, oxygen is still always a -2 when it becomes the oxide ion. 2 times -2 is a -4. So our lead has only one atom to spread the whole +4 charge over, so it's going to be lead 4 oxide. Now, sulfur is right below oxygen, so our sulfide ion is a -2 charge. It's a 1-to-1 ratio, so that must mean our copper has to be a +2, so it is copper 2 sulfide. Our Fe and our O is always a -2, so it's a 1-to-1 ratio, and so it's a +2, iron 2 oxide. Our bromide ion is a halogen, it's a -1 charge. I have 3 -1 charges, so an overall -3 charge. I have one iron atom to spread over a +3 charge, so that makes this iron 3 bromide. All right, if we're going to go the other way, if we are given the name and we're going to write the formula, we first identify the cation and anion, balance the charges, and write the formula, cation first, using subscripts from the charge to balance. So, formula for iron 3 bromide. All right, well, we know iron's charged because it tells us right here, iron 3. Bromine's a halogen, it's a -1 charge. Well, we need 3 negatives to balance out the 3 positives charge. So I have Fe, Br3. Press pause and write the answers to this. Silver sulfide. Even though silver is in the transition metals, it has a fixed charge of +1. So we have our silver with a +1 charge, so we don't need to use a Roman numeral when we were writing that. So if you're wondering where the heck's the Roman numeral, well, it's not there because it's not a variable charge. Ditto for the zinc. However, iron 3 oxide, iron can be more than one charge, so that's why we put the Roman numeral there. All right, so now then, let's go ahead and start writing the formulas. So silver is a +1 charge. The sulfur, when it becomes a sulfide ion, is a -2 charge, so I'm going to need 2 silvers. Zinc is a +2 charge. Our chloride ion is a -1, so I'm going to need 2 of those -1 charges. Our iron 3 and our O2, we're going to need 2 of these +3 charges to balance out the 3 of the -2 charges. So when we put it all together, Ag2S, ZnCl2, Fe2O3. Now in the olden days, they didn't use Roman numerals. And you may go, oh, well, that's good. No. You also needed to know Latin in order to do it. But the ick and the us referred to the ick referred to the higher charge of a variable metal, and the us represented the lower charge. So the ick, so iron can be more than one charge, so the ick would represent the +3 and the us represented the +2. Or if we were dealing with copper, the higher charge was a +2, and you would have to know the name for copper, the Latin name, cupric, which would be the higher charge, and then cuprous would be the lower charge, the copper 1. Iron 3 chloride would have been ferric chloride. Iron 2 chloride would be ferrous 2 chloride. So the point is, you don't have to know the overall Latin and everything, but in our health professions, they still use the ick and the us sometimes, even though 40 years ago I was promised that this naming was gone and I wouldn't have to know this.